Welcome back, friends. Today's topic is tautomerism. Tautomerism is also known as cryptomerism, metotropy, analomerism, even desmotropism or dynamic isomerism. Now, first I will discuss what are the structural requirements for tautomerism. The first requirement is molecule should have electron withdrawing group. For example, CO, NO2 or NO or double bond NH, that is imine. This withdrawing group should be attached to saturated carbon atom which has at least one hydrogen, and that carbon is called alpha carbon. Means molecule should have alpha hydrogen on saturated carbon. So this one is second requirement. Now see, this alpha hydrogen migrate from alpha carbon to oxygen of CO group. So actually hydrogen moves from 1 to 3, atom number 1 to atom number 3. That's why this is called triad system. What is this? Triad system. And these two isomers are always in equilibrium, and this is known as keto form and this is enol form. That is the most important in organic chemistry. Keto-Enol Tautomerism. This one, this is nitro group. So this is nitro. Again it shift like this, so it become this is nitro, this is called Ac nitro. So this is nitro Ac nitro tautomerism. Third one, this is nitroso group, again moves like this. And this is called oxime or isonotroso. So this is called nitroso, isonitroso tautomerism. Is like CH double bond NH and saturated carbon next to this group. This is called imine. So alpha moves like this. So we get this is imine and this is ene plus amine. Means it is enamine. So imine, enamine tautomerism. This is one type of open chain tautomerism and known as triad system. Why it is known as triad system? Because hydrogen moves from carbon atom number 1 to atom number 3. Keto-Enol Tautomerism, nitro Ac nitro tautomerism, nitroso, isonitroso tautomerism, imine, enamine tautomerism. Now let us discuss Keto-Enol Tautomerism in detail. First is, most simple example is this. This is ethanol acetaldehyde, but for the namesake we call it as keto because of this CO group. This is known as keto form. Now what is our requirement? we should have electron withdrawing group, that it has. We need alpha hydrogen, that it also has. That means tautomerism takes place. So hydrogen shift from this carbon to oxygen. So this is the enol form. But keep in mind, in simple keto form, equilibrium is largely towards keto form. Means this enol form is very less. Means 99.99% we have keto form. Why is it so? Why keto form is more than enol form? Because C double bond O bond is stronger than C double bond C bond. So this is the reason why keto form is more than enol form in simple ketones. 99.99% we have keto form and only 0.01% we have enol form. Same is the case with acetone. Again keto form. What is its enol form? See, both sides we have alpha hydrogens. So one of the alpha hydrogen migrate from this side, carbon to oxygen, and equilibrium largely lies to keto. It is again 99.9% around. I mean to say that keto form is dominating over enol form in case of simple aldehydes and ketone. Simple aldehyde and ketone means which have only one CO group. Now come to the next one. Let us discuss some other example. If we have, this is 1, 2, 3, 4, 5, 2, 4 diketone or 1, 3 diketone we can say. If this is the case, see, this CO has this alpha hydrogens. We have choice of alpha hydrogens. These two are of same type, but this is different because this is attached to CO from both sides. That means which hydrogen is most acidic? Obviously this one, because it has electron withdrawing group on both sides. So this hydrogen will migrate. Now if it migrate, it is like this. So we get CH3 COH double bond CH C double bond O CH3. Now first look at these structures. In this case, this CO separated by next CO by two single bonds, means no conjugation. But when we form its enol form, see, lone pair, double bond, separated by single bond, when they are in conjugation, this double bond and CO double bond separated by single bond, again conjugation. That means this is whole system is conjugate. There is no conjugation and this is conjugated system. The first factor which favors this enol form is conjugation. And second factor, this OH and CO, they form hydrogen bond. Because this OH has partial positive charge, O has partial negative charge, so there is a formation of intramolecular H bonding, and because of this enol content is 92%, means enol form is better than keto form, 92% in hexane. Now next point, solvent also affect the keto-enol content. If we have non-polar solvent, it favors the formation of enol form. But if we have a non-polar solvent, it favors enol content, because non-polar solvent cannot form hydrogen bond with any compound. But if we have polar solvent, polar protic solvent, then that stabilizes the keto form. That stabilizes the keto form by forming hydrogen bond. Because of the presence of these keto groups, they form hydrogen bond with polar protic solvents. So keto form is more than enol form in case the compound is present in polar protic solvent. For example, in this case, only 15% of enol form is there in water, because water is a polar protic solvent, but hexane is non-polar. So non-polar solvent favors enol content and polar protic solvents favor keto form. Now let us compare percentage of enol content in different compounds. Okay, so let us discuss the enol content of these 6 compounds. Which one has higher enol content and what is the order of enol content? So let us discuss one by one. In first case, you can say, this is the example we have discussed earlier. There is a conjugation. When it's enol form, we form either this side or other side, because both are of same type. There is increase in conjugation as well as formation of intramolecular hydrogen bonding. That's why enol content is high. We come to this. Phenyl group increases the resonance of keto form, because this is behave as an electron releasing group. So it becomes CO, it makes CO single bond, O gets negative charge, and that's why this hydrogen shift towards this oxygen and we get again there is hydrogen bonding as well as increase in conjugation, and in enol content increase in conjugation is more than in keto content. That's why if we compare enol content of these 2 compounds, which one has higher enol content? Obviously this one, because in this case conjugation is more on enol content of molecule containing phenyl group. And if we compare 1, 2 and then 6, it will increase more than this, because when we have 6th, this methyl group is also replaced by phenyl, whole conjugation across the molecule. That's why 1, 2 and 6 enol form of 6th is greater than 2nd, which in turn greater than 1st. So this is for the enol content of 1, 2 and 6. What about 3 and 4? See, in this case, methyl, but this part, methyl of the other part is replaced by OCH3. Now there is cross conjugation. CO group is involved in withdrawing electron from this carbon as well as from oxygen, because this lone pair pi bond, this is in conjugation. That's why enol content of ethyl acetoacetate is always less than acetyl acetone. Now come to this part. Out of third and fourth, now you can figure out which one has higher enol content. This one has higher enol content. So out of third and fourth, fourth has higher enol content than third. But about this. Now in this case, again enol content can be formed because it has hydrogen on saturated carbon. This alpha hydrogen form this double bond, pi bond shift towards oxygen and H plus, so we get enol, and surprisingly this is phenol, and phenol is aromatic. So keep in mind, if enol form of a compound is aromatic, that is always form 100%. Means this is always in the form of enol. Phenol is the most stable form of this compound. That means the equilibrium is always on this side. That means fifth has maximum enol content, then sixth, second, first, fourth, third. This is the order of percentage of enol content, right? Now like this, it has only enol form, no keto form. There are few compounds which have only keto form, no enol form, like this molecule. In this case, these are keto, we have alpha hydrogens, so enol form can be formed, but when we form its enol like this, double bond, OH, OH. This is enol form. But when we form its enol, it is, cyclic, planar, 4 and pi electrons. It is anti-aromatic. When enol form is anti-aromatic, it is highly unstable. It cannot be formed. So equilibrium lies towards keto form only. A term used in those cases where there is a possibility of 2 or more tautomeric forms, but only one is formed or only one exists, is known as pseudo tropism. So this is a case of pseudo tropism. Only keto form exists. Last example, this one. Only enol form exists. Keto form is 0%, 100%. So these are studied under the heading of pseudo tropism, right? And other examples which have only one form, like this molecule, when we form is enol form, see these are alpha hydrogens on saturated carbon, so tautomerism is possible. 1, 2, 3. So we get this compound. This is aromatic, so it always exists in aromatic form. This does not exist. Again, the case of pseudo tropism.